If z is normally distributed, determine the probability that z is between negative 1.36 and 0.43 using the standard normal table. In order to do this, we need to use multiple inequalities in order to find this probability. We know that the probability that a is less than or equal to z, which is less than or equal to b, is actually equal to the probability that z is less than or equal to b minus the probability that z is less than or equal to a. Given our own probability numbers, we can write the probability that z is between negative 1.36 and 0.43 as the probability that z is less than or equal to 0.43 minus the probability that z is less than or equal to negative 1.36. Because of the second component, the probability that z is less than or equal to negative 1.36, we need to use another inequality. We know that the probability that z is less than or equal to negative a is equal to 1 minus the probability that z is less than or equal to a. So our final equation will be as follows. The probability that z is less than or equal to 0.43 minus the quantity of 1 minus the probability that z is less than or equal to 1.36. We now can go to the table and find our two probabilities. First, we will find 0.04 along the left-hand side and 0.03 across the top. We can then find that 0.6664 is our probability for z is less than or equal to 0.43. Now to find the second, we can find 1.3 along the left and 0.06 across the top. We can then find that this probability is 0.9031. We can now go back to our z-score functions and plug in the numbers that we have found. Rewrite the standard notation for these probabilities. And now we can substitute in the numbers we found from our standard normal table. We found 0.6664 minus 1 minus 0.9031, which we will find to be 0.6664 minus 0.0969, which finally is 0.5695. So using the standard normal table, we have found that the probability that z is between negative 1.36 and 0.43 to be 0.5695.